Sixth grade, we've got a test coming up on shapes, area, perimeter, volume, and whatnot. So I thought I'd make a little video to tell you exactly what you need to know for this test coming up. All right, now we're going to start off with three things. There's going to be a couple of videos that you can watch to really help you with this next test. But first things first, there are some shapes that you need to know. You need to know them like the back of your hand. Okay, you need to be able to calculate the area and perimeter of these three shapes without even really thinking about it. All right, the first shape is the rectangle. Be a good idea to, if you're watching this video to help you study for the test, to take some notes on the video. Okay, so there are three shapes you need to know. There's one, the rectangle. Number two, the triangle. And number three, we know it, we love it, the circle. Okay, now every shape that you that's going to be on this test, and for the most part in 6th and 7th grade, every shape that you're going to see is going to be some combination of rectangles, triangles, and circles. They could be quarter circles, they could be half circles, they could be weird composite figures. But if you know these three shapes here, and you know how to calculate the area and perimeter of these three shapes, you're going to do just fine on any test I give you. Okay, now let's take a look at our first example here, the rectangle. Here's a rectangle. It's a rectangle because it's quadrilateral with 4 right angles. Okay, you're not going to be responsible for knowing that, but I just thought I'd throw that out there. Okay, so there's two things that I want you to be able to calculate for rectangles. First of all, I want you to be able to find the perimeter. Okay, I want you to be able to find the perimeter of a rectangle. And I hope you know by now that a perimeter of any shape is just the distance around the shape. Okay, it's the measure around the shape. Now in this, so it's like if I were here at this corner and I walk all the way along this line here on this edge, I make a left and go up here, I go around over here, and then I come back to where I started. How far did I travel? Okay, that's the perimeter. It's the distance around the shape. Well, there is a formula for this, but I'm not even gonna, I just want you to know that. You can look at this and see, well, I'd have to walk 6 meters plus 4 meters here. Oh, and then this side is the same length, so I'd have to walk another 6 meters. That would get me here, and then another 4 meters to get me back to where I started. 6 plus 4 is 10, plus 6 plus 4 is another 10, so this is going to be equal to 20. All right, so perimeter, always distance around the figure. Okay, we're going to do a couple of examples, and then we'll get to a formula for perimeter. Now the area of this figure, area, remember when we're talking about area, we're talking, here I'm talking square meters, and what I want to know is how many. Each one of these things here, by the way, is a square meter. It's a square that measures 1 meter by 1 meter. Okay, that's how we measure area, how much something covers, is with these little squares. When we're measuring area, we see things like square inches, square feet, square meters, square centimeters, and that's what these things are. They're squares that measure 1 meter on each side. So what I want to know is how many of these square meters could I fit into the rectangle? Well, let's see. The rectangle measures 6 meters long by 4 meters wide. So that means I've got 1, 2, 3, 4, 5, 6 squares in every row and 1, 2, 3, 4 rows, which means my area is going to be equal to, I can multiply these two things together. It's going to be 6 times 4. And that's equal to 24. Okay, now let's get some formulas out of this. This measurement here was called the length, and this measurement here is called the width. So how long your rectangle is and how thick or how wide the rectangle is here. That's length and width. Let's see what I had to do to the length and the width to find my perimeter and area. And let's come up with some formulas. Well, for perimeter, what I had to do was I had to add this, that's 1 length plus width, and then I had another length and another width. So that's 2 lengths plus 2 widths, and that right there is the formula for perimeter of a rectangle. You take double the length and add it to double the width. And we're going to take this out and move it in a second. The area of a rectangle, okay, the area of a rectangle. What did I have to do to find this area? How many squares I could fit inside? Well, all I did was I multiplied the length times the width. And that's true for all rectangles. Okay, so let's go ahead and take this little box here. And I don't really know where I want to put this right now. We're going to clear the screen in a second. But these are your formulas for area and perimeter of a rectangle. Okay? Twice the length plus twice the width. Well, you don't even need to really think about that. Just think about walking around the rectangle. The area of a rectangle is always going to be the length, that's one side, times the width, that's the other side here. That'll get you area. Okay, so now that we know that, let's go ahead and just hold on to this. I'm going to get everything else off the screen, even part of my G. And let's draw another rectangle here. Boom, here's my rectangle. Let's fill it in with a nicer color. There we go, here's my rectangle. Let's say that this rectangle measures 5 centimeters by 12 centimeters. Ooh, I completely blew it on units in my example. Okay, let's bring up the formulas. Here are our formulas. Okay. All right, now I want to find the perimeter, first of all. I want to find the perimeter of this figure. Well, that's going to be, let's see, my length is equal to 12 and my width is equal to 5 centimeters. So I'm going to take this formula and I'm just going to plug in the length and the width into this formula. Okay, so my perimeter, and I'm just going to use a capital P, is equal to double the length, that's 2 times 12, plus double the width, that's 2 times 5. And this is equal to 24 plus 10, which is 34. Now, since we're talking about length, my units here are going to be centimeters. Okay, now let's do area. It's not very neat, but I guess it'll have to do. The area, I'm just going to use big A for area. The area of this figure is going to be the length times the width. Well, that's going to be 12 times 5. Which is equal to 60. Now 60 what? Well, we're talking about area, so my units are going to be square centimeters. Okay, here's my perimeter, here's my area. And I got that by using these formulas here. Okay, let's go ahead and do one more example here, and then we'll move on to other shapes. Okay, let's say that I've got I'll call this a we're going to call this 3 feet by 8 feet. Okay, let's find our perimeter. Okay, our perimeter, P, is going to be equal to, well, I'm going to double 8. Okay, you can even do this in your head. You don't have to do the substitution. You can just say, okay, well, that's 16 plus double this, 6. Bam, you're done. You don't need to put too much thought into this. You don't need to write out the full formula. Double this plus double this, 16 plus 6, 22. And that's going to be feet because we're measuring distance. Perimeter is distance. The area is going to be length times width. That's 8 times 3. 8 times 3, I'll write it down, is equal to 24. But what are my units? Since we're talking about the little squares that go inside here, these are going to be square feet. Okay? And that's all there is to it. Okay, that's how you calculate the perimeter and area of a rectangle. Let's go back here. All right, on to our next shape. Our next shape is going to be the triangle. Let's see, I want to have plenty of room here. So let's take this, even the bottom of my G. I'll give you your bottom G back. There we go. Yeah, that's not bad. Okay, so let's see here. Perimeter means the same thing. So the perimeter, and I'm just going to use capital P for perimeter because I don't want to write perimeter every single time, is the distance around. And there's no real formula for this. We're just going to add up the sides. Okay? We're just going to add the sides. There's no formula for the perimeter of a non-equilateral triangle. Okay? So this is going to be 3 plus 4 plus 5, which of course is equal to 12. 12 what? Well, we're talking distance, so that's going to be 12 centimeters. Okay, the area of a triangle. Now, to calculate the area of a triangle, we need to know two things. I'm going to give you the formula first here. The formula for the area of a triangle is going to be the base times the height divided by 2. Okay, now the thing about the base and the height is they always connect, they always touch each other at a 90-degree angle. So this cannot be the base in this particular drawing. I mean, actually, I'm just going to show you, it could be the base if we did this. If we took this triangle and we flipped it so this was on the ground, okay? So this could be my base, but if this were the base, I'd have to know this measurement right here, how tall the triangle is from the base. But obviously we don't want to do that. Why don't we want to do that? Because we have a nice right angle here. So we have a base given to us and we have a height given to us, okay? So what we're going to do is we're going to plug these numbers in. That's my formula. Area equals base times height divided by 2. So that's going to be 3 times 4 divided by 2. 3 times 4 is 12, divided by 2 is 6. Now we're talking about area, so these units must be square centimeters. Okay, now where did this come from? Where did this formula come from? Well, if you picture this, let's just finish a shape here. I'm going to draw this out here like so. Oh, that's ugly. That didn't work at all. It's not going to be a perfect rectangle, but you can think of this triangle as being half a rectangle. Now, how would I calculate the area of this rectangle? Well, I'd have to multiply 3 times 4. That would be the area of the entire rectangle. But obviously, this is a rectangle that's been cut in half, so that's why we say base times height divided by 2. Okay, let's try another triangle. So, to recap, perimeter of a triangle, you just have to add the sides together. Add the 3 outside sides. If you see a dotted line like this, that is not part of your perimeter. It's only the lines on the outside. Okay. The area of a triangle, this is the formula that you need to remember. The area of a triangle is base times height divided by 2. Okay. This. Where was I going with that? I guess that was just a recap. Okay, let's get rid of everything. And let's try another couple of examples. So let's say I've got a triangle this time that is going to be 5 by, well, let's call that 12. And this side is going to be 13. Okay, so let's go ahead and make these inches. 5 inches by 12 inches, and this side is going to be, 13 inches. All right, so I want to find two things. I want to find the perimeter of this triangle, and I also want to find the area of the triangle, but let's start with perimeter. Perimeter, like I said, is just 5 plus 12 plus 13. So 5 plus 12 plus 13. 12 plus 13 is 25, plus 5 is equal to 30. 30 what? Well, we're talking distance, so this is going to be 30 inches. Don't forget your units. Even though I did in my very first example in this video, don't forget your units. The area of this triangle is going to be the base times the height divided by 2. Okay, now what is the base and height? Well, where's our right angle? That's what we need to do. To find the base and the height, I mean, I've got 3 sides. 2 of them have to be my base and height, I suppose. 2 of them have to be the base and the height in this problem, so we need to find the right angle. Well, this is clearly not a right angle, nor is this. That means this is my right angle, and it is. It looks like a nice right angle. So that means that my base is going to be 12 and my height is 5. So the area of this triangle is going to be base times height divided by 2. 12 times 5 divided by 2. 12 times 5 is 60, divided by 2 is 30. What are my units? Ask yourself that question every time you do one of these problems. We're talking area, so we're talking how many little squares can I fit in here? In this case, square inches. Okay. Let's do one more example. And I'm going to keep this formula over here so we can reference it. And that's area is equal to base times height divided by 2. Okay, let's go ahead and draw this one here. This one's going to be, nope. Let's do that. I don't like that. Now these are not going to be exact numbers. I mean, the numbers work, but they're not going to make sense with the picture. It's not drawn to scale, I should say. Okay, so we're going to say that this side here is 5 centimeters. This side here is 5 centimeters. This side here, obviously it's not, but I'm going to call it 6 centimeters. Okay, and then you have this extra piece of information that tells you that this height here, well, I shouldn't even tell you this, the height, that this little dotted line is 4 centimeters. Okay, so let's go ahead and find the perimeter and the area of this figure here, this shape, this triangle. The perimeter is going to be the sum that's adding together all the individual sides. Well, that's 5 plus 5 plus 6. Why am I not adding the 4? Because it's not an external side. This is just a measurement to help us solve this problem. So that's going to be, the perimeter is 5 plus 5 is 10, plus 6 is 16. 16 what? Well, we're talking perimeter, we're talking distance. So that's going to be just regular old centimeters. Centimeters measure distance. The area. Okay, I'm looking for a right angle. I don't see one in the triangle. What that means is this measurement here is important. We're going to say that the 6 centimeters is my base. Okay, 6 centimeters is my base. Now to find the height, if you know your base, to find the height, what you have to do is you have to go up to the very highest point of your triangle from the base and measure the distance, like drop a rock straight down from here and measure the distance that it falls. Okay, so if I went up to the top of my triangle and dropped a rock, it would fall 4 centimeters, which means that 4 centimeters is the height of my triangle. All right, so the area of our triangle is going to be base 6 times the height, which is 4, divided by 2. 6 times 4 is 24, divided by 2 is 12. What are we measuring? Area, how much this triangle covers. So that's going to be square centimeters. And that's it, all there is to it. I'm going to do one more tiny example just to prove a point here, kind of. All right, let's say that we've got a triangle that looks like this. Well, that's a bad example, actually. We've got a triangle that looks like this. How do you know base? Let's say this is 10, this is 4, and this is 5. And then you've got a measurement here that looks like it would be about 2 or something like this. How do you know base height? How do you know what your measurements are to calculate the area of this triangle? Well, what you have to do is visualize. You've got to find a right angle somewhere. Now, there's no right angles in this triangle. The only thing that's close to a right angle, or the thing that is a right angle, and it will usually tell you in the problem, is this right here. That tells me, in my mind, what I have to do is visualize this triangle being flipped around until this side is my base. in which case this distance here, this rock falling straight down, which was 2, would be my height. Okay, so that's just a little bit about finding base and height. And we'll cover that in class better than I did here. Okay, so to recap, for triangles, to find the perimeter, add all the sides together. I'll even write that down. To find the perimeter, add all external sides. Now that's kind of, what's the word? I don't need to say an external side, but I just want you to know that when you see a dotted line inside the triangle, that's not part of the perimeter. So just add the solid lines that are on the outside of the triangle. Okay, this is starting to take longer than I thought, so let's move on. Circles, last shape. Now circles are really cool because you only have to know one thing about a circle to calculate everything about a circle. And that one thing is the radius. If you find the radius of a circle, you can calculate anything. All right, now I'm not going to show the proofs for these formulas. You just need to memorize them, and we've been working with them a lot. Now, the perimeter of a circle, we don't call the perimeter. We call it the circumference. Okay, and how do we find the circumference of a circle? Well, there's 2 formulas. One that's related to the radius and one that's related to diameter, but they say the same thing. So the formula you know is 2 pi r. If you know the radius, multiply it times 2, multiply it times pi, and there's your circumference. That is the distance around this circle. So if you started here and you walked all the way around this circle and you got back here, you would have traveled the circumference of the circle. Or you could say if this was a wheel and it rolled from here and it rolled all the way over here until it was back to touching this point on the ground, well, it would travel the circumference of the circle. Okay, so circumference, we're talking distance. Distance. The area of a circle is equal to, oops, I forgot the other formula. Another way we can say the formula for the circumference of a circle is just diameter times pi. Okay, and again, we'll usually be using the 3.14 for pi here. We're not really worried about being exact and using pi. But I want you to see that, well, we know this, that double the radius, here's double the radius, is equal to the diameter. So these really are the same formula. Okay. And finally, the area of a circle is equal to pi r squared. Now, a good way to remember that this formula here goes for circumference and this formula here is for area is that when we measure distance, we measure in things like inches, centimeters, feet. And when we measure area, we measure in square inches and square centimeters and square feet. So the formula for the area of a circle has the exponent, has the second power for an exponent here. Okay, get rid of this. Let's do this real quick. All right, so let's calculate the circumference of this circle. The circumference of this circle, and I'm just going to use capital C, is going to be, well, I know that this is the radius. It's 6 centimeters. So that means it's going to be 2 times pi times the radius, which here is going to be 6. Okay, pull out our calculator. 2 times 3.14 times 6 equals 37.68. 37.68 what? Well, since we're talking distance, we're talking centimeters, not square centimeters. Okay, the area of this circle, I'm going to be using this formula, and that's going to be pi times the radius, which is 6, but I need to square that 6. Okay, so the 6 gets squared first, then I multiply times pi. So that'll give me 6 times 6 times 3.14, 113.04 here is equal to 113.04. Now that's not an area yet. How do I say area? Well, we're going to be talking about square centimeters. Okay, so circumference, centimeters, area, square centimeters. Okay, let's go ahead and do another example here. I have to get rid of this. Delete all this and delete all this. Let's draw another circle really quickly. Okay, and this circle is going to have, should fill it in first. Don't know why I like to fill it in so much, but I do. Okay, let's say that this circle's radius, it's not a bad radius, is going to be 7 meters. Okay, give myself some room here. 7 meters. Let's go ahead and find, first of all, the circumference, which is very similar, analogous is the word, to perimeter. It's the distance around. Okay, now if you don't remember, that's going to be 2 pi times the radius. Okay, so we're going to multiply 2 times pi times 7. And usually it's okay to use a calculator here. 2 times 3.14 times 7. I messed up somewhere. 2 times 3.14 times 7. It's obviously not 400, so that answer didn't make sense. I immediately redid it. Let's see here. What did it say? 43.96. 43.96. Now, what are my units? Well, we're talking distance. We're talking distance around. So these are just going to be plain old meters. The area of this circle, we're going to be using the same formula for the last one. Pi r squared. So I'm going to take my radius, which is 7, square it, and multiply by pi. And that's going to be equal to, let's get our calculator out, 7 squared is 7 times 7, times 3.14. 153.86. 153.86. What are we talking about? We're talking about how much the circle covers. We're talking about area. We're talking meters squared, or square meters. Okay, one more example for circles, and then we'll wrap up this whole thing. Here's my circle. Fill it in. And now we're going to say that the diameter here, I know that's not a perfect diameter, but we're going to say that the diameter is 10 centimeters. Why not? Okay. Now I need to find the circumference. Well, I know that the diameter times pi is circumference. So diameter times pi is circumference. So that's just going to be 10 times 3.14. And I can just move this decimal place over 1. So that's going to be 31.4 centimeters. We're talking distance. I'm kind of rushing through this one because I want to get to this point here. To find the area of the circle, we need the radius. We don't have a formula that relates area to diameter. So I need to find the radius. And it's pretty easy to do. We just take the diameter and cut it in half. So my radius here, and I'll even make a little note, the radius is 5 centimeters. So my formula is going to be pi times 5 squared. You know, I don't even need to be doing parentheses here, but I'm showing you that I'm substituting. But anyway, let's keep going. So this is going to be 3.14 times 5 squared is 5 times 5. And that gives me 78.5. 78.5. What are we talking about? We're talking coverage, we're talking area, we're talking square centimeters. Okay, so in this problem, I had to divide the diameter by 2 to get my radius, and then I squared that, that's here, and I multiplied by pi to get 78.5 centimeters squared. Yeah, we're going to stop with that. Let's go back to our background here. Okay, so let's just put up some quick formulas here. I'm actually going to take this and blow it up so I've got room. Okay, so the perimeter of a rectangle was equal to double the width plus double the length. The area was the length times the width. Triangle perimeter, we don't really have anything. I'm just going to say add all sides. And the area was equal to base times height over 2. Similar to perimeter, but not the same word, I guess. The circumference of a circle, that's big C, was equal to 2 pi r, or we could say diameter times pi, same thing. And the area of a circle is equal to pi r squared, okay? This you must know, especially these 3. Actually, these 4, because you need to know the formula here. These 2, you can just kind of piece it together in your mind, like you don't need to memorize formulas. But these 4 you absolutely do need to know. And that's it for now. So if you have any questions, let me know. I hope this video helps you study for the test.